Good evening, Miss Anita. We are Group 5 and our group's title project is Metallurgy in Construction and Infrastructure. Our group consists of 4 members, which is Erine, Siti, Nurezati, Lakhsan, Kumar, which is me, and Hamas Rabbani. To introduce our title means metallurgical processing is crucial in meeting the demands of modern construction, such as taller and more complex structures with superior mechanical and physical properties. By optimizing the structure and processing of metals, metallurgy enhances safety, longevity, efficiency, and sustainability. Additionally, metallurgically processed materials exhibit improved mechanical properties, making them ideal for infrastructure like skyscrapers and long-span bridges. Their high resistance to mechanical stress, weather, and extended service life are very important. This assignment discusses key metallurgical techniques and their significance for the evolving construction industry.
Assalamualaikum, my name is Erine from Group 5. Today, I will briefly explain about the metallurgy properties of structural building materials and their crucial role in the construction of buildings and bridges. Metallurgy deals with understanding of the properties of materials, especially metal, which directly affects how we design and build safe, durable structures. The key properties that we need to focus on include strength, ductility, toughness, hardness, corrosion and fatigue resistance, moldability, and thermal expansion. These factors determine how material behave under different loads, temperature, and environmental conditions. Among structural material like reinforced concrete, timber, and fiber reinforced material, steel is often preferred. Why? This is because it is incredibly strong, versatile, and durable. Steel is typically made of iron and carbon with other elements like manganese, chromium, and nickel, which is added to improve the performance of the steel. Moreover, the microstructure of steel also matters. It is divided into 3 types, which is perlite, that is strong and hard, and it is widely used in construction. Moreover, perlite, which is softer and ductile and suitable for low stress area. And the third microstructure of steel is martensite, which is extremely hard but brittle. It is used in reinforcement bars. We also enhance the steel properties through heat treatment process to relieve stress, refine the grain structure, and improve corrosion and wear resistance. For material selection that depends on applications, normally in buildings, we need steel that is ductile, corrosion resistant, and can withstand fire and earthquakes. Meanwhile, for bridges, we use tough, fatigue-resistant steel to handle both static and dynamic loads. Ultimately, a strong understanding of metallurgy results in safer, longer-lasting, and more cost-effective structure, support sustainability, and improve the overall integrity of our built environment. That's all from me. Thank you. Then I will pass the presentation to the next person.
Assalamualaikum, my name is Siti Nurezati and I'll be presenting about corrosion issue in infrastructure and mitigation techniques. So for the case study 3, it is based on building Second Bridge, officially known as Sultan Abdul Alim Muazzam Shah Bridge. So the corrosion issue regarding this case is the corrosion of steel reinforcement inside the concrete piers, caused by a chloride ion from salt-laden air and seawater. So this results in cracking, spalling, which is breaking of concrete surfaces, and structure weakening. So the contributing factor for this issue is the high humidity, splash zone exposure, and poor concrete permeability. So the mitigation technique used to counter this problem is the first one, impressed current catalytic protection, ICCP, which is controls the corrosion through electrochemical reactions. So the second one is the corrosion inhibitor, which is applied to the concrete surface to reduce chemical reactions. And the third one is protective coating, and we use epoxy or polyurethane to shield the surfaces from the corrosions. As for heat treatment in structure and infrastructure component study case 4, it is based on the world's tallest building, Burj Khalifa in Dubai. So the structure still for this infrastructure require exceptional mechanical property to withstand compressive and lateral stresses, high temperature, wind and seismic pressure. So in order to obtain this mechanical property, heat treatment techniques is used. The first one is quenching and tempering, which apply to the structure steel. Example, STM A913 grade 65. To produce binti and temper martensitic microstructure. This will improve the tensile strength and the ductility of the steel. And the second method is to use stress relief annealing, which is applied to the specific part to enhance dimensional stability and lifespan. And the third one is post-weld heat treatment, which is PWHT. It is used at critical joints to relieve residual stresses from welding, and this will prevent deformation and fracture of the structure.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Today my group and I will present a topic titled Metallurgy in Construction and Infrastructure. Metallurgy is the science of metal and it plays a critical role in construction. It helps us choose the right material, strengthen them, and protect structure to ensure long-lasting, safe, and efficient building and bridges. For example, structural steel is widely used because of its strength, durability, and flexibility. In this presentation, we highlight some key points. First, we explain the essential properties of structural material, such as strength, toughness, corrosion resistance, and weldability. We also discuss several real-world case studies. The first is the Penang Second Bridge in Malaysia suffered from corrosion due to sea exposure. The solution was to use ICCP, corrosion inhibitor, and protective coating. And the next is Burj Khalifa, use heat-treat steel like quenching and PWHT to withstand high pressure and extreme temperature. And the next is Merdeka 118, use advanced metallurgical technique such as normalizing and cast hardening for high-performance steel. And the next is the Sydney Opera House, apply IoT technology to monitor energy efficiency in real time. And in Sweden, the hybrid project has successful produce fossil-free steel, cutting carbon emission by 95%. We also highlight future trends such as green steel, AI, and digital twin for smart construction, modular construction, and net zero energy building. In conclusion, metallurgy is not just about metal. It's about creating stronger, safer, and more sustainable infrastructure for the future. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.